Human biology evolved to navigate forests, rivers, and plains. Our brains are hardwired to process miles and meters, leaving us poorly equipped to comprehend the true distances of deep space. We establish our baseline reality right here. Low Earth orbit, just above the atmosphere, is the absolute outer limit of daily human experience. To reach our nearest neighbor, the Moon, you have to cross 384,400 kilometers of unbroken vacuum. Looking back from the lunar surface, Earth becomes an isolated blue marble suspended over a gray, desolate horizon. This diagram shows the scale of that gap. Every other planet in our solar system, aligned side by side, fits neatly between the Earth and the Moon. Yet, to map the rest of our neighborhood, we must shrink that entire gap down to a single speck. Our everyday sense of distance fails out here. To understand the cosmos, we must set aside intuition and rely strictly on the math. The gravitational anchor of our system is the Sun. Beside this churning mass of plasma, Earth registers as a microscopic speck. Crossing millions of miles past the rocky inner planets brings us to Jupiter, marking the beginning of the outer solar system. Pressing further outward to Saturn, the distances between planetary orbits multiply. The astronomical rule is simple. The further you travel from a star, the more aggressively the void expands. This radar chart plots the orbits of Jupiter, Saturn, and Neptune. The physical volume of these giants is negligible compared to the immense black voids between them. As sunlight spreads across these expanding gaps, it dilutes, leaving the outer planets in a dim, freezing twilight. Our solar system is a staggering expanse of dark, empty vacuum that happens to contain a few tiny islands of matter. Pushing past Neptune's orbit, we enter the deep interstellar dark. Out here floats humanity's most distant physical outpost, the Voyager 1 probe. It is a fragile construction of metal and wire, swallowed by the surrounding starfield. It has been traveling at tens of thousands of miles per hour for nearly 50 years to reach this coordinate. But the gravitational boundary of our solar system, the Oort cloud, is still far beyond its reach. This logarithmic chart maps the total distance Voyager has covered against the thousands of times greater distance required to finally breach the Oort cloud. Even at its current maximum velocity, it will take Voyager tens of thousands of years to clear that final outer shell. Humanity's furthest physical triumph of exploration has barely scratched the surface of our immediate cosmic backyard. If we jump all the way to the threshold of the next star's nextum, Alpha Centauri, and look backward, our entire solar system simply merges into the background noise of the Milky Way. Absorbing this level of exponential reality forces a paradigm shift that cannot be unlearned. It is difficult to map a vacuum this deep without feeling a sense of human insignificance, but the silence of the void also provides the only context that truly matters. Compared to the crushing pressures of the gas giants and the frozen radiation of deep space, our world is a physical anomaly. These distances emphasize that for now and for the foreseeable future, this fragile oasis is the only home we have in the dark.